ये आपका रिलेशन एंड फंक्शन का पार्ट 3 वीडियोस है। सीबीएसई स्टेट बोर्ड दोनों के लिए थ्योरी एग्जाम्पल सेम है। फर्स्ट एग्जाम्पल हियर टू, let R be a relation on Z set defined by R is equal to AB order pair such that A is less than equal to B. Check R is reflexive, symmetric and transitive. Solution: test reflexive. Let small a is element of Z, that implies small a is less than equal to small a. Here one condition satisfied, a is equal to a, that means a is less than equal to a, that implies a is element of R, so R is reflexive. Then you test symmetric. Let a be element of R. A be element of R means we write a is less than equal to b. A less than equal to b. That implies we cannot say b is less than equal to a. That implies ba is not element of R. So R is not symmetric. Next to test transitive. Transitive means let a be element of R, B is element of R. Then we have to verify that S is element of R. Let a be element of R and B C element of R. A be element of R means we write A is less than equal to B, and BC is element of R means B is less than equal to C. That implies here A less than equal to B and B is less than equal to C. That means A less than equal to C. That implies SC element of R. So R is transitive. Next example 3, that is important example. Let L be the set of all lines in a plane and R be a relation on L defined by R is equal to L1 L2 order pair such that L1 is perpendicular to L2. Check R is reflexive, symmetric and transitive. First to test reflexive. Let L1 is element of L. Then we cannot say one single line is perpendicular to this line. That means L1 is not perpendicular to L1. That implies L1 is not element of R. That implies so R is not element of R. So R is not reflexive. Next, we test symmetric. Let L1, L2 is per element of R. L1, L2 element of R means we write L1 is perpendicular to L2. We write L1 is perpendicular to L2. One line is L1 is perpendicular to L2. That means L2 also perpendicular to L1. That means right L2 is perpendicular to L1. That implies L2 L1 is element of R. So R is symmetry. Next test, transitive. Let L1, L2 element of R and L2, L3 element of R. L1, L2 element of R means we write L1 is perpendicular to L2 and L2, L3 is element of R means we write L2 is perpendicular to L3. Here see, suppose L1 is perpendicular to L2. L1 is perpendicular to L2. L2 is perpendicular to L3. That is your L3. Here L1, L3 is not perpendicular. That means we write L1 is not perpendicular to L3. That implies L1, L3 is not element of R, so R is not transitive. Clear example 3. Next, example 4. Example 4. Let R be a relation on Z set defined by R is equal to AB order pair such that two divides A minus B. 2 divides A minus B. Check R is reflexive, symmetric and transitive. Okay, test solution. Reflexive. Here R is your given, R is a relation AB order pair such that 2 divides A minus B. 2 divides A minus B means A minus B is divisible by 2. Reflexive, let small a is element of Z set. That implies A minus A is equal to 0. We write A minus A is equal to 2 into 0. 2 into 0 is equal to 0. So A minus A is divisible by 2. That implies here A minus A is divisible by 2. That implies A is element of R. So R is reflexive. Symmetric next. Let every element of R. Every element of R means we write A minus B is divisible by 2. That implies A minus B is divisible by 2. Mathematically we write A minus B is equal to 2 into some constant K. K is element of Z set. That implies B minus A, that is minus 2K, Then we write b minus a is equal to 2 into minus k. That means b minus a is divisible by 2. That implies b minus a is divisible by 2. That implies ba is element of R. So R is symmetric. Clear? Next, we test transitive. Let A be element of R and B C element of R. We have to test A be element of R and B C element of R, then S is element of R. A be element of R means we write A minus B is divisible by 2, and BC element of R means B minus C is divisible by 2. Mathematically we write A minus B is equal to 2 into some constant k1, and B minus C is equal to 2 into another constant k2, where k1, k2 element of Z set. Then adding two equations, A minus B plus B minus C is equal to 2k1 plus 2k2. That implies here B be cancelled, then A minus C is equal to, taking common 2 into k1 plus k2. That means A minus C is equal to 2 into some constant, means A minus C is divisible by 2. A minus C is divisible by 2. That implies SC element of R. So R is transitive. This relation satisfies reflexive, symmetric, and transitive. We also say this relation is an equivalence relation. Clear examples? Please like, share, subscribe for more videos. Thank you to all.